Okay. You just listen to what I'm saying and you'll recall. So in the normal case, what we have is, suppose we take a toy car, which is like this, okay, like this, and anyone who is sitting, and suppose this is a table, this is a tabletop, and these are legs of the table, and suppose you are pushing this toy car like this with a force of, let's say, 5 newtons. So what will happen after some time, this toy car will reach somewhere over here. Am I right? This is the position where it will reach. That means it has moved some distance in some time. This is the distance s in what? Let's say 3 meters. Okay. In some time t, maybe 5 seconds or 10 seconds. So the complete, if you push this horizontally, the full 5 newtons is completely utilized to move this toy car from point A to point B. Now we know that the work done just C is equal to force dot F dot S, which is equal to F cos theta, okay, into displacement S in meter. Now, theta is the angle between the force and the displacement. See, both are in the same direction. We are applying the force in the same direction towards right hand side, and displacement is also towards right hand side. This is the force, and this is direction of displacement is also toward right hand side. So if force is also this way is force and displacement is also this way is s, so the angle theta becomes 0 degree. So cos 0 degree is equal to 1. So it will be f into cos 0 degree into what? 3 meters. Okay, 3 meter. So it's 5 newtons complete into 3 meters. Why? Because cos 0 degree is equal to 1. Got it? So this is 15 Newton meter is the work done, which is 15 joules. This is the case one of ninth class. What do you call this? Ninth class level, where we don't tell also whether you are moving in the cos theta. Now comes the 11th level. Now 11th level, it's there in ninth also, but yes, now we don't write so much. Now in 11th level, what happens, if you remember, this same force is not fully utilized because it is pushed at an angle. What is that angle? I draw over here. Now this is the theta angle. How much? Let's say 30 degrees or 60 degrees. Okay. Now some part of the force will be used upward, which the toy car won't move upwards, but some part will be moved toward right hand side. So some component, the right hand side component is the horizontal component called F cos theta. Okay. And force is what? 5 newtons. Cos 60 degree is what? Half. Okay. Sine 30 is half, so cos 60 is half. So 5 into half, that is 2.5. So only 2.5 Newton will be used multiplied by the distance, let's say 3 meter. So you'll have how much work done? 5, 2.5 Newtons multiplied by 3 meters. Okay. So 3 5s are 15, 1. 3 2s are 6 and 1, 7.5 Newtons. No, not Newton, Newton meter. That is what? 7.5 joules of work will only be done. So actually, if you understand, this is having two components. Which two components? This is having the force is what? Having one horizontal component in yellow color and one vertical component over here in the green color. Can you see this part? This is a vertical component. This is a horizontal component. This is the angle theta. So if you see, this is what is the component. The polar representation is exactly the same as the breaking up a force into two components. This topic and the force, okay, the dot product is exactly the same. There's no difference between them. The representation is a little bit what? uh, in terms of x and y. Even representation is also same. So this part, just take a picture of this once. Okay, screenshot of this. Just take a screenshot of this. Okay, and save it so that you can make your notes. Now I'll rub this part and I'll explain this much in a more better way. This one. Okay. Okay, I'm rubbing this. Fine. So I'm rubbing this. I clear all. So just see, this was your this was your, let's say, the floor, and this was the toy car. Only I'm talking about the force was being pulled by the child. That is what? In this way. What it? 5 newtons. And here I forget everything and I say, this is my theta. What is this? Angle theta. Here. And I drop this what perpendicular. So this is your right angle triangle. This is the hypotenuse. O, A, B. OB is your hypotenuse. Clear? And OA, if I drop it over here, OA, OA 90 degree, OA is your base. Okay, what is this? Base, note it down. And AB is your same as this. AB is this right angle triangle. So this is your AB, which is same as what? This thing. So you have two components. One was, suppose this is now position vector, which is the what? Nothing but the 5 newtons. 5 newtons is your position vector R. Why? This is the coordinate system. So this 5 newtons R, this is the angle theta, which is equal to 60 degree. So you have two components, 5 Newton cos theta. So this component is what? F or 5 newtons, okay, into cos theta. Clear part? Or R. You have 5 newtons as a force is R, the position vector. So R cos theta is right down horizontal component, and R sin theta will be what? Will be R sin theta will be this much. That is a perpendicular. So perpendicular right down is equal to R sin theta, and base is equal to R cos theta. Clear? And if you add, if you apply Pythagoras theorem,